This video is on the objective solve linear trigonometric equations in tangent and cotangent, or really tangent or cotangent, one or the other. This is number 2. Alright, so hopefully you've seen the first video on this objective and other videos I've put up on other objectives when you're solving linear trigonometric equations. That's where you isolate the trigonometric function, get the trig function alone, and then hopefully there's some nice number on the other side to where you can go around the unit circle once and figure out angles that have that tangent or have that cotangent or whatever. Alright, so let's take a look. So again, if you want to see more about this, what they have to say about it, how they're instructing you, click on More Instruction, read their notes, look at their examples, watch their videos, and hopefully those help you. Right, so we're asked to solve the following equation for theta, right? Find the values of theta that can replace here and satisfy this equation, make it true. Now, remember, and you've seen this before, if a trig equation has a solution, it's going to have infinitely many solutions because the trig functions are periodic. So they don't want all infinitely many solutions, right? They just want the values of theta that range from 0 degrees to 360 degrees. All right. Okay, so I'm going to write out this equation here. We have negative 5 times the square root of 3 times the cotangent of theta plus 1 equals 16. Alright, so the first thing I'd be doing would be subtract. I want to isolate this cotangent of theta, right? Get that alone. So I'd be subtracting 1 first. We have negative 5 times the square root of 3 times the cotangent of theta. Must be equal to 15 then. And then I would divide by this negative 5 times the square root of 3. Alright, so we have cotangent of theta. Now 5 goes into 15 3 times, and it's a positive divided by a negative, so it'd be negative. Then 5 goes into 15, so you have 3 in the numerator, square root of 3 in the denominator, and this would actually simplify to just negative square root of 3. Alright. So we're looking at this equation. When is the cotangent of theta equal to negative square root of 3? Or if you'd like, if for some reason you don't like working with cotangent, you'd rather look at tangent. Once you've got the function isolated like this, you could take the reciprocal of both sides. Say, hey, the reciprocal of cotangent is tangent, and the reciprocal of this number would be negative 1 over the square root of 3. Negative 1 over the square root of 3, but when you rationalize, that would be the square root of 3 over 3, right? So solving this equation is equivalent to solving this equation. All right, so now what I'm going to do is I'm going to think about just going around the unit circle one time, counterclockwise from 0 to 360 degrees. I'm not going to actually draw the unit circle or anything, just going to visualize it. I've seen it enough. Hopefully you have by now too, to where you can picture it. And just think of the angles. What angles have a cotangent of negative square root of 3? Alright, so it's got to be an angle in quadrant 2 and quadrant 4. Right? Got to be an angle from both of those, because those are where tangent and cotangent will be negative. Now, the angles that the angle in quadrant 2 that has a cotangent of negative square root of 3 or a tangent of negative square root of 3 over 3 would be 5 pi over 6, or 150 degrees. So I'm going to start writing out the general solution here, right? Listing all possible solutions. So again, the one in quadrant 2 there, that would have this cotangent or this tangent, is 150 degrees. And you can double check that. Remember remember the sine of 150 would be a half, because reference angle is 30 degrees, right? And the cosine of 150 would be negative square root of 3 over 2. So sine divided by cosine would be negative 1 over the square root of 3, or square root of 3 over 3. The tangent would be this, or you flip it over and the cotangent would be that. Right? If you're more comfortable working with sines and cosines, right, just remember those. Now this works, 150 degrees, cool, but so does any, when I add on any multiple of 360. So I could add on 360 degrees times k, where k is an integer, and still get another angle with a cotangent of negative square root of 3. But again, that's not the only one, right? Those are all the quadrant 2 angles, but they're quadrant 4 as well. Now you could just add 180. Remember cotangent and tangent? Those have a period of 180 degrees or pi radians, so you could just add 180 degrees and get the angle in quadrant 4. That's 330 degrees then. All right, and this would have a reference angle of 30, so again, the sine would be a half. Well, the sine would be negative half, and the cosine would be positive square root of 3 over 2. And when you divide sine by cosine, get the tangent, you get negative 1 over square root of 3, or negative square root of 3 over 3. Or you do cosine divided by sine, you get negative root 3. So this is good. And then plus any multiple of 360. Right. Now, like I said before, the cotangent and tangent, you could have just had 150 plus any multiple of 180 because of the period of tangent and cotangent, but this is fine. This is a description of all the infinitely many solutions to this equation. Right. So I'm going to start listing a bunch, right, like I like to do. So I'm going to start listing solutions here, just for different values of k. Now when k equals 0, 150 degrees, 330 degrees, right? These are solutions. And then I'm going to just increase the value of k going this way. So I'm just going to be adding 360. Right, every time I increase k by 1, it just adds another 360 degrees. And going this way, I'll just decrease k by 1, and then I'll subtract 360. So some other solutions would be 510 degrees. Right, maybe 400 plus 110. Yeah. Add 360 again, 870 degrees. There's another solution, and so on. And subtracting 360 be negative 210 degrees, and so on. Right. And the same thing with the 330, right? Just keep adding 360, subtracting 360. You get more and more solutions. So 690 degrees for theta would be a solution, and so on. And subtracting 360, negative 30 degrees would be another solution. And I could do this all day long, right? Add and subtract 360 degrees to all these solutions and get more solutions. So what I have here for you are, 7 solutions listed to this equation, right? But they don't want 7 solutions, right? They want the solutions that are from 0 degrees to 360 degrees, right? So, all these solutions are too big. All these solutions are too small. It's only these two, right? Only the ones I initially stated, 150 degrees and 330 degrees. Those are the only ones that are solutions to the equation and also in that range that they desire. Okay, so back here, select all that apply. 150 degrees, 330 degrees. Okay, wonderful. So again, hopefully watching me do this, and looking at the more instruction if you get stuck, reading the answer explanations when they come up. Hopefully all this stuff helps you out when you're working on these problems on your own. And thanks for watching.